loaded. So that is one of the reasons I send the videos for some of these things ahead. And we don't have time. We are going to have this training for only 3 weeks. And the exam is coming up on the 20th of this month, 20th, 21st. So for people that are always asking for more time, you need to know now. Since you are aware that the exam will be coming up on the 20th and the 21st of this month for this particular class, we don't have time. There is no time for us. So you need to start preparing ahead. And don't forget what I said before. Every chapter or every week, all the assessment that needs to be written should be written that week. And when I'm done with my class, I will also say that again. Every class, I will try my best to remind you about the exam day, so that when we get to that period, people will not start calling me and telling me, please give me 1 week, give me 2 days, give me 3 days. That is very stressful. So we don't have that luxury of time. Okay, so I've used this code before. The journey of 1,000 miles begins with 1 step. If only you can take that step and be consistent with it. The key to what we are doing in this place is about consistency. It's about determination. It's about commitment, discipline and commitment. If you don't have the discipline, you don't have the commitment, you can't do this program. I see some people wrote mail to Cisco pleading that Cisco should talk to me to give them more time. That's one of the reasons why I shut down the class for last week. They don't have the time, they are busy, they are working and all of that. I agree that some people they may not have enough time, but the program is time bound, so we don't have luxury of time. You need to pay that price. If you sleep for 6-7 hours before, during this program, you may have to reduce your sleep to 4 hours. If you watch TV for many hours before, now you have to reduce the number of hours you stay on TV. Social media, you have to reduce the number of hours you stay on social media. So whatever you need to shut down in order to create time to study, do this program. You have to do it this period. We cannot follow your own timetable. You have to fit into our own timetable, because Cisco is doing you a favor. I told you, if you want to do this training all by yourself, per track is $500. But Cisco is paying for this, for you to have this training done. So let's try to be committed to this. That is the reason for all this, my long story today, before starting this class. Ali, can you do me a favor? Can you write a message on WhatsApp to tell people that we have started the class already, and copy the link and drop it again there? Please do that for me, because some people probably have gotten used to that break. They may not know we're in class already. So I'm going to talk about VLAN today. Now, some people may be saying, why didn't I talk about router configuration, switch configuration? That is what you have in chapter 1 and chapter 2. And I remember sending a video ahead of that. This is chapter 1 and chapter 2 of Sustainability. It's more or less like a revision of what we did in Sustainability 1 with basics router configuration, router and switch configuration. So I don't want to burn my energy on that again. That's why I have already taught some people, and that's why I send the recordings ahead. So by the time you listen to the video of the recordings for CCNA 1 and 2, CCNA chapter 1 and 2 that I did, then you are going to see that it's just a revision, even though there are some little things added. It's just a revision of what we have done before. So I'm going to go to something new, completely new, and that is called virtual LAN, local area network. Okay, so let's talk about VLAN. What is VLAN all about? Why do we need VLAN? So the objectives in this particular chapter, we're going to explain the purpose of VLAN in switch network. We're going to explain VLAN in the multi-switch environment. We're going to do the configuration of VLAN. We're going to talk about VLAN trunking, and then we'll talk about dynamic trunking protocols. For people that have listened to my video, this is just going to be like a revision to them, or if they have any area where they have issue, then they can now ask me question. So this is going to be like a walkover for those of you that have listened to my video. So overview of VLANs. So what is a VLAN? VLANs are logical connections with other similar devices. Now, I need to tell you something before we proceed. Let me chip this in before we proceed. Because some people don't understand some things, that the reason why we do what we do. And I don't want you to just do training just for the sake of doing training. You need to know why we do what we do. So remember, in our basic router configuration, we have two local area networks, LAN A, LAN B, and we use a router to link the two LANs together. You could have more than that, LAN C, LAN D. You use the router to link them together. We've talked about segmentation. We talk about different network addresses. We talk about different subnets and all of that. These are physical local area networks. So that means I need four ports on this router. 4 ports, 4 ports, 4 ports. So what this means is, before I can segment the network, I need to bring in a router. If I yank off this router now and connect all the switches together, that gives me just one flat network. The network is not segmented. So it is only the router that can segment the network by default. It is only the router that can break the network into different broadcast domains by default. But the router has a limitation. Let me give you the limitation. Let's say for Cisco router, the maximum number of ports I've seen on the Cisco router is 4 ports. I have seen another vendor's router with 12 ports. So like that vendor that I'm talking about, if I carry their router, it means I can use that router to break my network into 12 broadcast domains, different segments, different departments, just like I explained. You should put different departments on different segments or different network. With that, you achieve security and so on and so forth. But there are some scenarios where you have more than 12 departments, maybe like 60 departments, 100 departments, and beyond. How are you going to get a router with 60 ports, 20 ports, 30 ports? Because it is a router that breaks the network into different broadcast domains by default. So that is a limitation for the router. So if we cannot achieve that, we want to see how we can still segment our network without using a router. You know, by default, a switch does not segment network. What I mean by that is this. If I drop a switch here now, connect computer to this switch, drop another switch, connect computer to this switch, drop another switch, connect computer to this switch, drop another switch, connect computer to this switch. If I link all these switches together, depends on how I want to link them together. We're going to talk about network design later. This is just one big network. You want just one big network. If there's a broadcast from one segment, if there is a broadcast from here now, from one switch, let's say this switch A, switch B, C, and D. If there's a broadcast from switch A, it will enter B, from B it will enter C, from C it will enter D. Even if you like have 100 switches connected together, they just form one local area network for you, one big local area network. So if you have different departments, what's going to happen? Somebody is, please, can you mute? Somebody is echoing back to me there. So I'm trying to explain to you why we do VLAN. Why do we do VLAN? So we can't really segment the network by default with a switch. If you link switches together, they keep on expanding your LAN for you. And that is not a good design. By design, every network should be on a different segment. Every department will be on a different segment. That is the best design. So now they now say, okay, if that's the case, why can't we also use a switch to break the network into different networks? So this is what we are trying to say. This is a switch here. Switch. On this switch, we know before, if people are connected to this switch, they all belong to one network. But what we want to do right now, we want to connect these people to, we want to break this switch into like 3 or 4, let's say 4, and call this one VLAN 2, call this one VLAN 3, call this one VLAN 4, and call this one VLAN 5. So whatever is going on in VLAN 2, VLAN 3, people don't know about it. Whatever is going on in VLAN 3, 4 don't know about it. Whatever is going on in 4, 5 don't know about it. If there's a broadcast in 2, it can't enter 3. If there's a broadcast in 3, it can't enter 4. If there's a broadcast in 4, it can't enter 5. And yet they are on the same switch. So we are going to learn how to use the switch to break the network into different broadcast domains or different departments. So this can be a different department now. This VLAN 2 now, we can say maybe accounting, another VLAN maybe HR, another VLAN maybe management, another VLAN maybe admin or whatever. And yet we're on a switch. And the switch doesn't have what it takes to do that by default. But because we want to have multiple VLANs or multiple LANs like 60, 70, 80, 100, and the router cannot do that for us because we can't have plenty ports on our router to segment the network, we can also use the switch to segment our network. That is the ideal of VLAN. It's not a physical LAN, it is a virtual LAN, but it works. Did I communicate? So I'm just trying to give you a background of what we're trying to do here. Okay, so let's start the journey. So what is a VLAN? VLANs are logical connection. Take note of this. VLANs are logical connection with other similar devices. VLANs are logical connection with other similar devices. What do we mean by that? Look at what they had, the diagram we have in this place. We have a switch here, it's in first floor. We have another switch here, second floor. We have another switch here, third floor. This computer is in first floor, it's in VLAN 2. There's another computer at the second floor, it's also in VLAN 2. Other set of computers at the third floor, they are also in VLAN 2. It simply means my VLAN membership, listen very well, my VLAN membership can cross multiple switches. So what we are trying to say here is this. If there's a broadcast from this switch here, I mean from this computer here, it is only the computer here that are in the same VLAN that will hear it. And this computer here, the other computers in other VLANs will not receive that broadcast because they belong to VLAN 3, even though their VLAN membership scatters across multiple switches. So we can be members of the same VLAN, and yet we're on different switches. Let's say accounting now. I am on switch 1, you're on switch 2, another person is on switch 3, and we're all in accounting department, and we're all in accounting VLAN. We are grouped together logically based on department. Just like what you are saying in this place. You see, we have VLAN 2, they name it IT. VLAN 3, HR. VLAN 4, sales. And guess what? Every VLAN has a different network address. HR, look at the network address. Sales, look at the network address. And the VLAN can cross multiple switches. So you need to understand this. When we come to implementation, for people that have listened to my video, I know they are enjoying themselves now. So VLANs are logical connection with other similar devices. Placing devices into various VLANs have the following characteristics. What do we stand to gain when we implement VLAN? What do we stand to gain when we implement VLAN? It provides segmentation of the various groups of devices on the same switches. We segment the network. I've explained that. It provides organization that is more manageable. When you segment the network, when you do VLAN, you have control over different units or different departments because based on the VLAN they belong to. You know the kind of traffic that is coming from that environment, where they are going. So you can put your eye on those traffic. You can put your eyes on those traffic. Sorry. Broadcast, multicast, and unicast are isolated in the individual VLAN. If there's a unicast, it's only within our VLAN. If there's a multicast, it's only within our VLAN. If there's a broadcast, it's only within our VLAN. So VLAN cannot cross, let me say unicast cannot cross into another VLAN. Somebody in VLAN 2 here cannot just send a message and it will enter VLAN 3. For it to enter VLAN 3, then we need a router. But if what we intend to do is we don't want it to enter VLAN 3, we just limit the conversation within that group. Now listen to this now. Each VLAN will have its own unique range of IP addressing. Take note of that. I'd like to put it this way. VLAN equal a subnet. VLAN equal a subnet. VLAN equal a subnet. So if I have 10 VLANs, that means I need 10 different subnet addresses. If I have 20 VLANs, I need 20 subnet addresses. 30, 40, 50, 60, like in our institution, I think we have over 60 VLANs based on different departments. Each department is given a VLAN and is a subnet. VLAN equal a subnet. Take note of that. And it gives us smaller broadcast domain. So when you create VLAN, you have reduced the effect of broadcast domain. And that is the reason why we don't put all the departments on the same network. We want to reduce the effect of broadcast. And I've explained that in one of the classes. Well, I said the reason why you do segmentation is because you don't want broadcast to start and consume the whole segment. So you break the network into small chunks or small segments, so you can curtail the effect of broadcast. So those are the advantages of VLAN. So these are more or less like a repetition again. What are the benefits of using VLAN? You get smaller broadcast domain. You improve security. What do we mean by improve security? If I have student VLAN and I don't want students to talk to staff, that's a good idea. Instead of putting everybody on one flat network, I'll create a VLAN and drop the student in one VLAN. And they will never be able to talk to staff. If there is a virus or malware that has ravaged that VLAN, we don't have problem in another VLAN. They are the only one that will enjoy the virus there. It improves IT efficiency. It reduces cost. You know why? Because one switch can create multiple VLANs for you. So I can use a switch to segment my network into as many as possible. So I don't have to go and buy a router with multiple ports in order to segment my network. Then I have better performance because of smaller broadcast domain, and that improves bandwidth. And I can manage my network, the traffic very well because I have different segments. I can pinpoint down traffic. Let me see my eye on a particular segment. Say what's going on in this area. Who is consuming my bandwidth? Why is the network slow? Who is stopping our bandwidth? So you can pinpoint down the culprits to a particular VLAN. So these are things you enjoy when you do VLAN. So you can see another example in this place. We have VLAN 10, faculty, VLAN 20, student, VLAN 30, guest. And look at on the other side, so another computer belongs to VLAN 10, is also in faculty. Another computer is a student computer, it belongs to VLAN 20. Another computer is in guest, is on VLAN 30. This one are on a different switch, this one are on different switches, but the same VLANs on different switches can talk to themselves. 10 here can talk to 10 here. 20 here can talk to 20 here. 30 here can talk to 30 here. If we want all of them to talk to themselves, fine, we can do that. And that's what we're going to do in next class. But for today's class, we don't want people to talk to themselves. We just want to segment network and everybody's on his own. Am I communicating before I proceed? We have not done the configuration, no. Any question? Okay. Are you flowing? Thank you, Inyala. You are flowing? So I'm trying to just lay foundation, tell you the advantages. Thank you, Ali. Thank you, Mr. Davy. You people you're making me happy now. You flow, you're flowing with me. Okay, thank you. So when you flow, when you understand what I'm doing, what I'm explaining, just give me thumbs up or 777. So that means I can proceed. So now we have not come to the configuration. That's it for people that have not watched the video. Now, for people that watch the video are enjoying themselves now. We're going to come to configuration later. But we need to understand, we need to have a deeper understanding about VLAN. This VLAN thing that I'm teaching you people, let me tell you a story that I had many, many years ago. There's a company in Nigeria here, the one is imported. I think that's the right word. They imported people from outside the country to come and do VLAN for their organization because they didn't think anybody can do VLAN in Nigeria here. Many, many years ago. When I heard it, I said VLAN that we play around with in the lab. They have to import people. They have to bring in expatriates, what do you call them, from outside the country to come and do VLAN. You know, then I realized one thing with technology. Once you know something, it's not a big deal to you. And that is why people price us cheap. They try to price us cheap because they know we know some stuff. But if they are bringing people from outside the country and they can't find anybody that knows the things within the country, they pay heavily. This same VLAN we are going to be doing in this class, they imported people to the country to come and implement VLAN for them. Segment the network, because this is used mainly for big organizations and campus network. And when I say campus network, I'm talking of institution, university, where they have like 30,000 users, 40,000 users, 50,000, 60, 70, 100,000 users on the network. You can't but do VLAN. But in a small organization where you have like 30 people, 50, 100, you can just buy a router that has 4 ports and then put everybody on different segments. If the departments are not plenty or maximum 8, you don't need to do VLAN. But once you begin to talk about big organization, you don't have a choice. You have to do VLAN. So let's proceed. So there are different types of VLAN. Types of VLAN. The first one is the default VLAN. What is a default VLAN? VLAN 1 is a default VLAN. What is a VLAN 1? We didn't create it. It is on our switch by default. Anytime you drop a switch like this and connect computer to the switch, all those computers belong to VLAN 1. You are going to see, I will show you. So VLAN 1 is the default VLAN. That's number 1. VLAN 1 is the default native VLAN. What's default native VLAN? I'm going to talk about that later. And VLAN 1 is the default management VLAN. So VLAN 1 is default VLAN, is default native VLAN, and is a default management VLAN. And take note of this. It cannot be deleted or renamed. You can't delete VLAN 1. You can't rename VLAN 1. You didn't create it. So how do you check to see VLAN 1 or the VLANs created rather on the switch? When you enter your switch, you issue the command show VLAN brief. Show VLAN brief. Then you're going to see the VLAN 1 is created by default. It's on our switch. The name is default. The status is active. And guess what? All the ports on this switch, all of them are in VLAN 1. So if I plug on port 1, I'm a member of VLAN 1. If I plug on port 2, I'm a member of VLAN 2. If I plug on port 3, for all of us, if you plug on all these ports, we belong to the same VLAN. So when you get a switch and plug computers to the switch, even though you try to use the switch as plug and play, there is a VLAN created on that switch, whether you realize it or not. So if I add another switch, now cascade another switch, there are computers plugged here. All these computers on this place will also be members of VLAN 1. All the ones here will be members of VLAN 1. So that's why they can talk to themselves. Somebody is distracting us there. Carl, can you please mute your mic? Hello, Carl. Okay. Note, while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLAN. What does that mean? Even though VLAN 1 has been created by default, Cisco will tell you don't even think about using VLAN 1. Don't use it as a default VLAN. Don't use it as a default native VLAN. Don't use it as your default management VLAN. Why? Because the bad guys, the threat actors, are aware of VLAN 1. If they want to come and hack into your network, if they want to come and attack you, they know by default VLAN 1 is available on the network. And if you are making use of VLAN 1 to carry your traffic, then you have brought down one layer of the defense for them. So Cisco will tell you, even though VLAN 1 is created, do not use VLAN 1 for anything. Go and create other VLANs and use them for whatever you want to do. And that's what we're going to do today. So there are other VLANs. So we can have what we call a data VLAN. What is data VLAN? Is dedicated to user-generated traffic, email and web traffic. VLAN 1 is the default data VLAN. So VLAN 1 be kind of is everything here. Meaning when people are sending data to themselves, they are still using VLAN 1 to carry the traffic. Because all the interfaces are assigned to this VLAN. How? You will see. Native VLAN. What about native VLAN? This is used for trunk links only. What is trunk link? We're going to come to that. All frames attacked on an 802.1q trunk link, except for those on native VLAN. So what does that mean again? We are going to come to that. So when we talk about tagging, it's not all the frames that pass through in between switches that are tagged. We are going to come to that again. Then the next thing here is management VLAN. When you talk about management, you want to have a separate VLAN that you are using to manage the traffic, or let me say the configuration traffic. What I mean by that is this. You want to telnet into a switch. Where is the switch getting its IP address from? It must be a particular VLAN. You want to telnet, you want to SSH into a switch. So anything that has to do with SSH, telnet traffic, you shouldn't carry it with the regular data VLAN. So you should have a separate VLAN for managing your devices. And you are going to be in charge of all of this. So as we are going to proceed now, we are going to talk about, we are going to decide on, okay, we want to create a management VLAN, we want to create a native VLAN, we want to create a data VLAN. Which subnet are we going to give to management VLAN? Which subnet are we going to give to native VLAN? Which subnet are we going to give to our data VLAN? And so on and so forth. And I think this should be the last one here. You also have what you call a voice VLAN. In case you carry voice on your network, some people are not aware of this. We can carry voice on our network. The same infrastructure that we're using to carry data can also carry our voice. Same network devices, same switch, same router. All you need to do is to have IP phone on your network. And you configure the IP phone, have a server on the network where you have a database of all the users, their phone numbers and their name mapped together. So we can have something like this on our network. You can see a computer connected to the phone, and the phone is connected to the switch. They are still telling us we should create a separate VLAN for our voice in case you have voice VLAN. Why? That is the best practices out there. You are going to achieve high bandwidth. You are going to assure your bandwidth. You are going to be able to do quality of service. Those things are beyond the They are beyond this particular class. This voice is a different training entirely. You are going to avoid congestion, and you are going to avoid delay that is less than 150 milliseconds. So the way you should design your network when you have a voice network or when you have voice traffic, create a separate VLAN for voice. So separate VLAN for management, separate VLAN for native VLAN, or let me say we need to have management VLAN, we need to have native VLAN, we need to have data VLAN, and in case we have voice on our network, we're also going to have voice network. So this is one of the packet result activity that is recommended, but I'm not going to do this one. Okay, so let's go and do this. Let's build this network and see. We'll come back here. We'll come back here. Do I talk here more? No, let's build network. Let's build. Let's build and come back. So before we build, let's decide on what we want to build. So I want to create, I need management VLAN. Management VLAN. Don't forget we say VLAN equal a subnet. So I need to have a subnet for it. So let me say our management VLAN is going to be 200.100.100.0/24. Our native VLAN, we want to use 200.100.101.0/24. Our data VLAN. Now for data VLAN, I want to have two. What I mean by I want to have two is this. I want to have data VLAN, let's say accounting, 200.100.102.0/24. Then another data VLAN, I want to have, let's say HR, 200.100.103.0/24. So these are the subnets we are going to be making use of. The only data traffic we are going to have now is our accounting and HR, 102 and 103. Native VLAN, this is what we have decided to use. Management VLAN, this is what we have decided to use. So how do we make sense of all of these things? You're going to see now as we proceed. So when we talk about the data VLAN, for instance, now I'm simply saying anybody from accounting, this is where they'll get IP addresses from. And then data VLAN for accounting, I can say number hit, let's say VLAN 10. For HR, let's number it and say VLAN 20, because you are going to name the VLAN and also give a number, or you give a number and name the VLAN. The same thing with our native VLAN and the same thing with our management VLAN. We'll give them number. So let's say this one is, you have 1020 here. Let's say 2 and 3. We give name, we give number, we name. We give number, we name. Now, I need you to understand something here. In my native VLAN, do I need to give people IP addresses from this subnet? We're going to find out. Management VLAN, who are the people that were picking IP addresses from this subnet? We're going to find out. But take note of this. So I need you people to have this addressing scheme done. Let's build on packet tracer, and we're going to come back later. So we're going to bring a switch here. For now, we're going to work with a switch. Later on, we'll make it 2 switches. So just like what I wrote down here, I'm going to type now. My management VLAN. Let me call it management VLAN. Let's say that should be VLAN V2, VLAN 2. And the subnet will be 200.100.100.100.0/24. Then we need another one. We call it native VLAN. let's say V3, and then the address is 200.100.101.0/24. That's another network. Then data VLAN, I will not just call it data VLAN, I will just say accounting VLAN. Or let me just say accounting and call it V10. That's VLAN 10. And the address will be 200.100.102.0/24. Then the last one is, let's say, HR. Let's say V20. HR is V20. That's VLAN 20. The address we have decided to give is 200.100.103.0/24. Don't forget, every VLAN equal a subnet. Every VLAN equal a subnet. We're going somewhere. Don't worry, by the time we land this plane here, for those of you that have not listened to the video, you're going to understand.
You have placed 5 octets.
You said?
5 octets. There should be 200.100.
Oh, sorry. Thank you, Ali. For all of them. Okay. I want to make my own IP address. Okay, thanks. So we're going somewhere. The first thing I need to do on my switch now is to create all these VLANs. I need to create management VLAN, name it VLAN 2. I need to create native VLAN, name it VLAN 3. I need to create accounting VLAN, name it VLAN 10. I need to create HR VLAN, name it VLAN 20. That's the first thing I need to do. And mind you, we have only one switch now. So I'll go to my switch, go to command line. Let's name this switch 1. Or switch A. Then, before I create, let me show you. Show VLAN brief. We saw that on my slide. Look at what we got in this switch. We have not done any configuration. And yet, there's a VLAN on this switch, name VLAN 1, or number VLAN 1, name default. And the status is active. And look at all the ports in the VLAN. And I've not done anything. So right now, we want to add our own VLAN. We want to create. Don't forget, we're not going to use VLAN 1 for anything, for security reasons. So we're going to go into global configuration mode and save VLAN 2, because that is the new VLAN we want to create. Name, say management. If I stop this, do show VLAN brief. You're going to see that my VLAN 2 has been created. Look at it. VLAN 2 has been created. The name is management and it's active. And guess what? No port is there. There's no port. So nobody can be a member of this VLAN 2 now. So I can go ahead also and create VLAN 3 and name it native. I'm using hop arrow key. So in VLAN 10, name it accounting or account. I think it's account. So account. Then VLAN 20, we name it HR. Name it HR. Now all these VLANs that were created, let's find out if they are on our device here. Now, anytime you are doing any configuration like this, don't forget what I taught you people. You build, you verify. You build, you verify. Don't assume things are intact. Always find, always verify. Use the commands, show commands to verify. So my VLAN 2 is created. The name is management. It is active. That's the status. VLAN 3 is created. The name is native, it is active. VLAN 10 is created. The name is account, is active. VLAN 20 is created. The name is HR, is active. So I have all my VLANs created. And I forgot to even point to this. Look at the prompt here. The prompt changed to VLAN configuration mode. When I just type VLAN 10, it changed from global configuration mode to config VLAN. That is what we call VLAN configuration mode. And guess what? I'm done. I've created my VLANs. So what am I supposed to do with these VLANs I created? I have decided to use my VLAN 10 as my data VLAN, meaning computers will be plugged there. Members of accounts department will be plugged in VLAN 10. I have decided to use my VLAN 20 as HR VLAN. Members of VLAN 20 will be plugged in ports that belongs to VLAN 20. But right now, VLAN 10 and 20 have no port inside of them, none. So I want to switch some ports into VLAN 10 and 20. So you are going to be the one to decide. Let's assume I want to use port 1 to 10 for accounting people that are in the accounting department. I want them to be using port 1 to 10. What will I do? I will move them into VLAN 10. Then let's assume I want to use port 11 to 20 for HR people. What do? I've moved those people out of VLAN 1 into VLAN 20. So anybody that plug on any of these ports, they belong to the same family. They are the same family member. So by the time I'm done with that, if there's a broadcast coming from port for Ethernet 1, it can't reach 20 because 20 is a different VLAN. So let's move ports 1 to 10. So let's start with 1. I'll go to that port. Interface fast Ethernet 0/1. The command is switch port access VLAN 10. What am I trying to do? I want to remove this port fast Ethernet 0/1 out of VLAN 1 and move it into VLAN 10. If I hit enter now, do the same command, do show VLAN brief. You are going to see port 1 has left VLAN 1. Is now in VLAN 10. So I want to move port 2, port 3, port 4, port 5, port 6, 7, 8, 9, 10. Will I be doing this thing one after the other since I have multiple ports? There's a way out. I can use a command called range command that will help me to enter multiple ports simultaneously. And the command is interface range Ethernet 0/2 spacebar dash spacebar 10. What's the meaning of that? I want to enter into port 2, port 3, port 4, port 5, port 6, port 7, all the way to port 10 at the same time. If I hit enter right now, look at my prompt here. Config if range. I am in 9 different ports simultaneously. Same command we issued at that time. Switch port access VLAN 10. I will issue that command. By the time I issue the command, if we go back and check, do show VLAN brief, you can see that all these ports have now entered VLAN 10. So it therefore means if you plug on port 1 and I am in port 2, you are in port 3, another person in port 4, another person in port 4, and so on and so on. We belong to the same VLAN. We are the only one that should be able to talk to ourselves. Nobody will talk to us. If there is a unicast within our VLAN, it's acceptable. If there is a broadcast, it's acceptable. If there is a multicast, it's acceptable. All of us in that VLAN are the only one that can talk to ourselves on the same switch. But guess what? Port 11 to 20, we want to move it into another VLAN. Same thing we did. Interface range command. 11 to 20. Switch ports. Access VLAN 20. Let's check if they're there. HR, we put 10 ports into HR. Port 11, port 12, port 13, port 14, port 15, 16, 17, 18, 19, 20. So if you are in port 1 and I am in port 11 on the same switch, we can't talk to ourselves. We're going to demonstrate it now. We can't see ourselves. It's not going to work. Even though we are physically connected to one switch, but logically we are connected to more than one switch. It's as if we are connected to two different switches or on different segments of a router. And we don't want to talk to ourselves. We don't have that capacity now to talk to ourselves. So what do I want to do now? Let me plug two computers on port 1 and 2, and two computers on ports 11 and 12. 1 and 2, 11 and 12 on this our switch. Port 1 and 2, 11 and 12. One and 2. Then 11 and 12. You and I know that 11 and 12 guys are in the VLAN 20. 1 and 2 are in VLAN 10. So we're good. We plug them. Now, the question is this. The guys that we plug in port 1 and 2, they need IP addresses. Where would they get it from? Who can answer that question? You can type. The guys that are plugged to port 1 and 2, they need IP addresses. The guys that are plugged to port 11 and 12, they need IP addresses. Which subnet are we going to give them IP addresses from? If you get the answer, you pay for my dinner. That's the reward for you. Nobody can answer the question? Ali, can you try? Can you people hear me? Oh, no idea. No, so you should not have a problem with that. Okay, good. You should not have a problem.
No,
So look at what I'm trying to say here. We have decided that VLAN 10 people will have this subnet 200.100.102.0. So all the guys in VLAN 10 will give them IP addresses from here. We are the one that decided on the subnet. Anybody in VLAN 20, which is HR, we give them IP addresses from here. If you have another department, you are the one to decide on the subnets. The VLAN ID, that's the VLAN number, the VLAN name, and the subnet. You are the one to decide. So these two guys here, I will give them IP addresses from VLAN 10. That is 200.100.102.0. These other two guys here, I will give them IP address from VLAN 20, 200.100.103.0 network. That is how it works. And now we're going to do manual. When we do DHCP, I will yank off these things. So let's do it. So I'll go to the first computer. I know you belong to VLAN 10 and I know your subnets. I'll give you an IP address from that subnet. Okay, Ali said I plug computer 1 and 2. No, I plug them on 1 and 2 now. Look at it. Look at the port number here. Can you see the ports? Ali, can you see the ports? See where I plug the computer? See? See? Can you see it? Ali, can you see? So I plug these two computers on port 1 and 2. The other two computer, oh, I think I made a mistake. The other two computer, like, that's what you're talking about. Oh, so that should be a mistake, sorry. Those ones should be on ports 11 and 12. You are right. Not 3 and 4. Thank you. Oh, notice. $11 and $12, because those are the, and now if you didn't tell me now, you know what would have happened? By the time we want to ping, it will not work. Then we'll start doing troubleshooting. 11 and 12. Thank you. You pay attention to detail. That's good. So right now, I'll go to this computer here, give this computer an IP address from the subnet it belongs to. So go to desktop, pick configuration. You say you are from accounting department. So your IP address is going to be 200.100.102. We can use .1, but I don't want to use .1 for now. I'll tell you later. Let's start from 2. This is your subnet mask. We don't have a router. The router is supposed to be our default gateway. We're good like that. So we give the second computer .3. Now the other two computers, these guys are from HR. They are from 103. Let's say 2 also. Oh, it's very valid. 200.100.103.2. We'll give the second guy .3. Not that we can't use .1, but I'm keeping that for the router when we do inter-VLAN routing later. Now you see, I have given these guys IP addresses depending on the VLAN they belong to. So let's go to this computer here and see if they can talk to themselves because they are members of the same VLAN. So let's check for this guy's IP address. This guy is 200.100.102.2. So his member is the 102.3. You see that they can talk to themselves. Anytime you see reply from, that means it's successful. So there's a reply from 200.100.102.3. The reply is successful. The numbers of packets sent is 4. Packet received is 4. The loss is 0. There's successful communication. So that is account people talking to themselves. Let's go and see if HR people can also talk to themselves. So HR is on 103.0 network. This guy is .2. So let's bring .3. You see the HR people can talk to themselves. So let's now see if we can cross border. What I mean by cross border, let's see somebody in accounting can talk to somebody in HR department. Ping 200.100.103.2. We have somebody on .2 in HR. So I want to try to cross border. Let me see if it's going to work. I can't talk to somebody in another department. That's unicast. Unicast will not go. Multicast will not go. Broadcast will not go. And yet we're on the same switch. So we have segmented our network successfully. What about the second computer on the other side? No way. So it is only people that belongs to the same VLAN that can talk to themselves on one switch or across multiple switches. We are going to do across multiple switches now. So if there's a student on the same VLAN on another switch, they will still talk. Somebody in HR is on another switch. As long as you are in HR, it doesn't matter where you belong, where you are plugged to. Even if you have 1 million switches, as long as we are on the same VLAN, we are going to communicate with ourselves. But once we are on different VLANs, even if we're on the same switch, we won't be able to communicate with ourselves. We can't talk. So the network is being segmented using a switch. And there is no router here. Any question? So we'll proceed. Are we together? Am I communicating? Question? Okay, if you are flowing with me, give me the sign that you are flowing. Thank you. Thumbs up, thanks. Mr. Yami, you're welcome. Good. All right, good. So the same thing we did here now, let's take it to another level. We want to add another switch because sometimes all the ports on one switch have been exhausted. We need to add another switch. So let's see what's going to happen. And have computer on the other side also. Let's say one computer from that. No, 2 is okay. So we can switch the port before we plug the computer. So let's connect the switches together. Switch to switch is crossover. Now, when we go to that switch, the same VLANs that we created on this side, same number, same name, we have to create on the other side. Same VLANs, management VLAN, native VLAN, and everything. So we're going to have to go to the other side and do the same thing. So let me confirm the names we gave here. Why are you telling me native VLAN mismatch? I have not touched that. Port 3. Okay, we'll come there. So let's check the VLANs that we created. Show VLAN brief. We have management. We have, that is a native VLAN. We have account. We have HR. So let's replicate this on the other side. So let's call this one switch B. So VLAN 2, name, management. VLAN 3, name, native. VLAN 10, name, account. VLAN 20, name, HR. And confirm all the VLANs. Show VLAN brief. So we have management VLAN here, it's active. We have VLAN 3, native VLAN is active. We have VLAN 10 here, account is active. And we have VLAN 20, HR is active. So all the VLANs are also here. Okay, so let's switch port just like we did on the other side. This VLAN 10 and 20 are our data VLAN. So let's say, let me yank off this cable from here and use a different port. Listen, I will explain that to you guys later, but it's not supposed to give us any error now because we've not done any configuration. Let me try another port. Let me gigabits. So back to that switch. So let's say show VLAN brief. Same thing we did. Let's move port 1 to 10 and then port 11 to 20 into account, then the other ones to HR. Same thing we did there. Interface range as Ethernet 0/1 spacebar 10. Switch ports access VLAN 10. Then the next one on port 11 to 20. Switch port access VLAN 20. Let's see if they're working. So VLAN brief. So in my VLAN 10, which is accounting VLAN, I have 10 ports switched there already. They must not be the same type of port. You can choose different ports on the other side. In VLAN 20, I have also 10 VLAN switch already. So I'll plug somebody on VLAN 10 ports, that is, let's say port 1. I'll plug somebody on VLAN 11, that is VLAN HR VLAN 20, and give them IP address based on the subnet they belong to, and let's see if we can cross border and talk. So let me plug this guy on port 1. and this guy on port 11. So the guy plugged on port 1 is in accounting department. The one plugged on port 11 is in HR. So let's give them IP addresses based on the subnet. So we've used 2, we've used 3. So we'll go to 4 for this guy here. So we'll say you are from accounting 200.100.100 dot 102 rather dot 3. Sorry, dot 4. We've used 2, we've used 3. Then we'll go to the other guy here. You are from HR. We give you 200.100.103.4, then the subnet mask. So let's now see if somebody here in accounts can ping his own member on the other side. Account is 102. He was pinging 103. Then we have somebody that is 104 on the other side on another switch, and they belong to the same VLAN. Let's see if he can ping. The ping is not going to go. Why? That's what we want to answer now. Why can't I ping somebody that is a member of my VLAN on another switch? We belong to the same VLAN. We are picking IP addresses from the same subnet. We should be able to talk to ourselves, but I can't go. Let's see if HR can go to the other side. Thank you. Those are the people that have watched my video. They say trunky. So let's ping the other side. This is HR 200.100.100. Okay, sorry, .103.4 on the other side. You will see that it will still not go. And this is a computer of the same VLAN on another switch. Why is it not going? Let's explain that now. We'll come back here and take care of this. So this is what we want to explain here. So when you have VLAN in a multi-switch environment, more than one switch, what is going to happen? Look at it here. We need to have what is called a trunk. What is a trunk? What is a trunk? A trunk is a point-to-point link between two network devices. Take note of. A trunk is a point-to-point link between two network devices. Like now, this is switch. This is another switch. We have a physical connection here. The fact that we have one physical connection, it doesn't mean that that connection is a trunk. So what is the job of a trunk? Cisco trunk functions. It allows more than one VLAN. This is key. It allows more than one VLAN. Now, let me tell you something. Those switches will plug together. Switch A, switch A, and switch B. Those switches will plug together. This port on the switch that I linked, it belongs to which VLAN? If you go and check, this port on the switch also belongs to which VLAN? Let's go and confirm that on our switches. I link gigabit 0/1 together. This gigabit 0/1, which VLAN do they belong to? The two of them on the two switches. So let's check. Show VLAN brief. Gigabit 0/1 is a member of VLAN 1 on switch A. Let's go to switch B. Gigabit 0/1, where do you belong to? Gigabit 0/1 on switch B is a member of VLAN 1. And guess what? It can only carry traffic for people in VLAN 1. And VLAN 2, we have VLAN 3, we have VLAN 4, VLAN 10 and VLAN 20. So how do we solve this problem? How do we solve this problem? Why is that my blank screen? How do we solve this problem? If we connected two switches together, switch A, switch B. This connection can only carry VLAN 1 traffic by default. So what if I have VLAN 2 traffic A? I have VLAN 3A, I have VLAN 10A, I have VLAN 20A. So the ideal thing will be to create a different connection for VLAN 2 traffic, a different connection for VLAN 3 traffic, a different connection for VLAN 10 traffic. When I say VLAN 10 traffic, VLAN 2, meaning you're going to move this port to be member of that VLAN. That's when they can carry the traffic. But you're going to be wasting cables and you're going to be wasting ports. So in order for us not to be wasting, so if I have 20 VLANs now, that means I need 20 different connections to carry different traffic from different VLANs. So in order for us not to waste these kind of cables and ports, they came up with the trunking technology. What does that mean? If I am connected on G0/1, 0/1, all I need to tell this port is you are a trunk port. Tell this other port also you are a trunk port. What have they created? A trunk connection. What does trunk that means? You don't belong to any VLAN. You are a member of all VLANs. Therefore, you can carry traffic for any VLAN. So VLAN 1 is coming, you can go through that link. VLAN 2 is coming, it can go. VLAN 3 is coming, it can go. 10 is coming, it can go. Even the VLANs you have not created, all of them can go through the trunk link. So when you configure a trunking on your switch, that port does not belong to any VLAN. Let's do it. Let me show you. We have confirmed now that this G0/1 is in VLAN 10. Look at it here. It's in VLAN, I say VLAN 10, sorry, VLAN 1 by default. Look at it here. G0/1, where we connected our the other switch. If I go to this port right now and change it to trunk port, G0/1, what's the command to change it to trunk port? Switch port, mode, trunk. Switch port, mode, trunk. Watch what is going to happen right now. I want to change this G0/1 to trunk port. I've done that. Let me issue that command again. Do show VLAN brief. You are going to discover that you can't find that port in any of the VLANs again. It's not in VLAN 1. It's not in VLAN 2. It's not in VLAN 3. It's not in VLAN 10. It's not in VLAN 20. You won't find it anywhere. Where did it go to? Because we told the port, you are now a trunk port. You don't belong to any VLAN. You belong to all VLANs so that we can use it to carry our traffic. I'll go to the other switch and do the same thing. On the other switch also, I showed you, show VLAN brief. You see that port here? What is the port here? Oh, I know what happened. Oh my goodness. Let me see something. Show interface trunking. Trunking has taken place, but I don't want it. I'm going to talk about auto later. So let's just move and yank that port into and put the port into OO. So interface G0/1, switch port mode, trunk. Now, that's what I want to do. I will explain this automatic dynamic trunking protocol later. So right now, by the time I do that on both sides, let us now see if the switches are formed trunk. If they are formed trunk. Command time, show interface trunking or trunk. Now you can see I have a trunk port or trunk connection. It's on G0/1. The mode is on. When you see the mode is on, it means I did it manually. Encapsulation, that is the tagging now. I'm going to talk about tagging later. Is 802.1q. The status is trunking. Look at the native VLAN we talked about earlier. Native VLAN 1. What is native VLAN all about? When the two switches want to discuss, want to have communication between themselves, they send that traffic, that control traffic on VLAN 1. And we don't want that too. That is the reason why we decided to create a native VLAN. What's our native VLAN? Show VLAN brief. Our native VLAN is VLAN 3. We want the switches to be communicating using VLAN 3. So we can tell this switch, We don't want you to talk to yourself on VLAN 1. Use VLAN 3 as your native VLAN. So we can go to that port they use to connect to themselves. And say switch ports encapsulation. I used to forget that command. Let me look for it. Switch ports. Let me. Sorry, just a minute. Should be switch ports, then mode, trunk. No, switch port mode. What? So that's how we look for command that we forget. So if we forget the command, I think switch port trunk. Yeah, switch port trunk native. Then VLAN 3. You see what I'm doing? Switch port trunks. Please mute your mic. Switch port trunk native VLAN 3. Please mute your mic. Switch port trunk VLAN native VLAN 3. Remember, we created that VLAN 3. We said that's what we want to use for our native VLAN. So we're telling this switch now, we don't want you to use VLAN 1 as your native VLAN. So on that port, we hit enter. I'll go to the other side and also do the same thing. Switch port trunk native VLAN 3. So it's a way of securing my connection between the switches. So the hackers are not aware that I'm using native VLAN 3. So I can go back to my switch and say show VLAN brief. Oh no, show interface trunk is what I wanted to put. Now you can see what we got here. My native VLAN is what now? VLAN 3. But we have created a VLAN 3, don't forget. That's the only reason why we created VLAN 3. Even though we have a subnet for VLAN 3, we're not going to pick any IP address from VLAN 3 to use for anybody. All we want to use VLAN 3 for is when the switches are talking between themselves, they should carry the traffic over VLAN 3, not VLAN 1, because VLAN 1 is not secure. The hackers are aware. VLAN 3, they don't know whether we're using it or not. That is the reason for that native VLAN that we created. Now let's test if these guys can talk across border, across switches, different switches. Now that we have created our trunking, so let's see if they can talk 200.100.102.4, which is on the other side. We see that this guy can cross border to the other switch. How come he can cross border? Because there is trunking between the two switches now, and our traffic can be carried over the trunk link. Let's go to the HR people. Let's see if HR also can cross border. Before we saw that the HR couldn't cross border to the other side. Let's see if HR can cross border. If HR has no cross border, then we have a problem somewhere. Oh, why are you not crossing? Troubleshooting time. So when you are doing configuration and some things are not working accordingly, then it's time to troubleshoot. What's this guy's IP address? IP config is 200.100.103.2, and we're trying to ping 103.4. So why can't we reach 103.4? Let's see if there's somebody with the IP address correct. Let's confirm. IP config. Okay, we have somebody with the IP address. So why can't we reach the guy? Are you plugged to the correct VLAN? It's on port 2. Can you see the mistake? But on the switch, this is not how to confirm it. You're not from the physical connection. Show VLAN brief. The people in VLAN 20 are from 11 to 20, but I plug on port 2. How will I know that I plug on port 2? I think there's a command, show interface status also. show interface status. So look at my port 2. Port 2 is connected. But the port 11 that is supposed to be my port that I intended to connect is not connected. Nothing is connected there. So I made a mistake. So I have to yank off that guy from port 2. See, I made a mistake here. Put the guy on port 2 instead of port 11. Because the guy belongs to a different VLAN, a different subnet. So I move the guy to port 11 and then wait for this link to turn green. Then we try to ping again. So it does not matter where you are located. We are logically grouped together in the same VLAN. We must be able to talk to ourselves. We should be able to ping. And that is the ideal weights that is the ideal of this VLAN. So let's see if we can ping on this guy to the other side. Ta-da! We can ping now. Did somebody just give me thumbs up now? Make it bigger. This is what the imported people from outside the country to come and do. Yeah, thank you, Ali. So that's it. Anytime you have more than one switch, your man should go to trunking immediately. If it's not working, trunking. If you've done trunking, it's still not working, probably you put people on the wrong VLAN on that switch, on the other switch. You like add 10 switches, add 20 switches, 30 switches, 40, 50. It doesn't matter the numbers. As long as we're members of the same VLAN, we can talk to ourselves. Now, one more thing before we go back to our slides. You see that we've not made use of management VLAN at all. What do we use management VLAN for? My switches also need IP addresses. Where will they get their IP addresses from? They have to get it from management VLAN. We don't lump it up with the data VLAN, no, or the native VLAN. So I could have 10 switches, 20, 30, 40, 50, 60, 100. In some organization, they have more than that. All my switches, they need IP addresses from a particular VLAN and a particular subnet. And in this case now, we have decided our management VLAN is 200.100.100.0. So I'll start giving my switches IP addresses from .1, .2, .3, and so on and so forth. So how do we give the switch IP address? I'll go to this switch. Should have started with that. Go to global configuration mode and say interface VLAN. What's our management VLAN? When we did basic configuration of switches, how did we give our switch IP address? I said interface VLAN 1. That's how you give the switch an IP address. I am changing it now because I have told you do not use VLAN 1 for anything. And we have decided our management VLAN is VLAN 2. So we are not going to say interface VLAN 1 on this switch again now. We are going to say interface VLAN 2. Then IP address 200.100.100. I could have used .1, but I want to use it for the router later. I will pick .2. Subnet mask 255.255.255.0.
ايه
Who is that? Okay. So I gave switch A 200.100.100.2. Now I'll go to switch 3. Same thing I did here. I'll go to interface VLAN 2 IP address 200.100.100.3 255.255.255.0. No shot. So if I have another switch, the same thing, another switch. So even if I have 100 switches, they will pick their own IP addresses from this management VLAN. That is the essence of management VLAN. to manage my devices. So I can ping these switches IP addresses. I can telnet to these switches IP addresses. That is the essence. I don't mix it up with data network or data VLAN. Am I making sense, guys? So look at our topology again. We started the journey, we built the network, we got management VLAN, native VLAN, account VLAN, HR, and all of that. Now we decided that our account VLAN and HR are going to be data VLAN, meaning people will be sending data. Native VLAN will make use of it. Management VLAN, you see what we are doing with management VLAN now. So now I can go to one switch now and try to ping another switch. In fact, for my computer, I can ping my switch. Let me ping from one switch to another switch for you see. Ping 200, 100, 100, dot, no, no, dot, yeah, 100, yeah. The 3, that's the switch on the other side. People. Now for switch to, when you switch and router replies, this is what you see. You see exclamation mark. So this switch A can ping switch B. That's management traffic. It's not data traffic. I can try to SSH into that switch. I can telnet into that switch. That's management traffic. It's different from data traffic. So you should put your switches on a different VLAN and on a different subnet. All the switches on your network, you should pick IP addresses from this particular subnet. Any question? Oh, we still have a long way to go. If you look at the video I sent, it's 3.5 hours or so. That video that I first sent to you guys on VLAN and inter-VLAN routing, chapter 3 and 4, because I taught a class and we did the two topics together. So for people that have listened to the video, they know the next thing now, but I don't want to go there with you guys today. Next class, I'll go to inter-VLAN routing. But if you have already finished that video, I will send the labs after this class, because now from now on, every topic there are labs to be sent. You launch the packet tracer, you work on the packet tracer activity, and then you are good to go. So let's finish the remaining story. So our Cisco trunk functions, it allows more than one VLAN. Extend the VLAN across the entire network. It doesn't matter the number of switches you got. By default, it supports all VLANs. And it supports 802.1 trunking. 802.1 trunking is a tagging mechanism. Tagging is a way of, okay, now let's say we have two switches now, and there is trunk. If VLAN 1 traffic are passing, VLAN 2 are passing, 3 are passing, 4 are passing, when they get to this switch, how would this switch know that this message is from VLAN 2, it's from VLAN 3, it's from VLAN 4? They have to be tagged. And there are two tagging methods. One is 802.1Q, the other one is ISL. ISL is dead now. The only one we use now is 802.1Q. So take note of that. That's a way of tagging. So when you have a network without VLAN, when there is a broadcast, it fills everywhere. I've explained that to you people already. The broadcast fills everywhere. A network without VLAN, broadcast fill everywhere. But in a network with VLANs, what happens? The broadcast is isolated in different VLANs. So there's a broadcast from this facility now, PC1, it can only go to this other PC here. Student will not know about it here because they are not on the same VLAN. Unicast will not. Unicast will go within VLANs. Multicast will go within VLAN. And broadcast also will go within VLANs. And of course, I've talked about the tagging. When you capture the frame, this is what you see, 802.1Q tagging. It uses 4 bytes to tag. That's the only thing we need to know here, the tagging method. We've talked about native VLAN and 802.1Q tagging. Now, there's one thing I need to also reiterate again here. When traffics are going through this trunk link, there is a particular traffic that is not always tagged, and that is the traffic from a native VLAN. So once this switch B here get a message from switch A, and the message is not tagged, switch B knows that that message is from native VLAN. That is between the two of them to communicate, to talk to themselves. So VLAN 1 frame is not tagged. But now that we have selected VLAN 2 as our native VLAN, it means our VLAN 2 frame also will not be tagged. So anytime you change native VLAN, the frame on that particular VLAN will not be tagged. So take note of that. And when you change the native VLAN on one side, like we change this one to native VLAN 2, you must also go to change it on the other side. If you change it on one side and you don't go to the other side, it's not going to work. And it is possible to have different native VLAN on separate trunk. What do I mean by that? If I have another switch here now, I can decide to say, okay, between these two switches here, I want to use VLAN 30 as my native VLAN. But I must create it on my switch, on these switches, before I can decide to use that VLAN 30. So you can have different native VLANs across between different switches. What if you have voice network? Of course, we can also tag our voice network. We can have a separate VLAN for voice. So what is going to happen? I need to look for that command. I can't remember the command. Let me look for the command for you people. No. It's not here. Okay, I will try to see if I can get the command across. So we can also tell our switch that on this port that is carrying data, we also have a phone block. Separate the data traffic from voice traffic. We can do that on the switch. And that is if you have voice on your network. If you don't have voice, then you don't need to crack your brain on that. You can see an example where, again, we should see the command ahead, where they already implemented the voice VLAN. By the time they issue this command, show interface fast Ethernet 0/18 switch port, it's telling us that it has access mode, that is for data, is VLAN 20, for voice is VLAN 150, on the same ports. Because if you look at that connection, a switch connected to phone and then connected to a computer. So it means data and voice are passing through the same port, but we need to separate the traffic by configuration. So let's try to see all the configuration we have gone through. We have done them on our own. So I'm just going to blast through here. So VLAN ranges, I didn't show you that. You can have up to how many VLAN is that? It's up to 4,000 VLANs or so. Okay, look at Catalytic switches 2960 and 3650 support over 4,000 VLANs. I don't think you need up to that. So normal range is from 1 to 1005. And this is used from small to medium-sized network businesses. And then 1002 to 1005 are reserved for legacy VLAN. 1002 to 1005 are auto-created and cannot be deleted, even though we are 1.2. And they are stored in VLAN.dats. I would say something about this before we conclude today. And VTP can synchronize between two switches. VTP used to be in the curriculum before, but the Cisco got rid of VTP from the curriculum. Then we have extended range VLAN, which is from 1006 to 4095. It is always used by service provider. I don't want to go into how they use it because they put different customers on different VLAN. That is when you are talking about service provider. That is another use of VLAN. And they are in running config, that is in our RAM. They support fewer VLAN features and it requires VTP configuration. But this is the one we are concerned with, the normal range VLAN. And that is the one we use most of the time. How do you configure VLAN? Every other thing is about the configuration. And I've done that already. But there's a command I want to point you guys to. I didn't talk about this. This is key for security reasons. When you enter the port on your switch, before you say access this VLAN, put switch port mode access. It's a security feature to tell your port not to form a trunk with any other thing. It's just going to be an access port. Only computer can plug to that port. When we come to security, switch security, I will talk more about that. And we've talked about how you can put port into VLAN. You can see switch port mode access. You can see switch port access VLAN 20. That is the port assignment. I think I'm looking for the one of data LANs. Okay, see it here. So sometimes you have a phone on the same port. So look at it, VLAN 20, name, student. They created the VLANs, VLAN 150, name, voice. Then they left the place. Now look at how they make use of this. They now enter into this port and say switch port mode access. Then switch port access VLAN 20. But for the voice, look at the command here. Switch port, voice, VLAN 150. This command is very important for you when you're talking about quality of service. But this one I want to really point. Switch port, voice, VLAN 150. So I can have voice and data simultaneously on the same port of my switch. So the switch will separate the two traffics to get from conflicting. When people are making call, it's a different traffic path. When people are sending data, it's a different traffic path on the switch. And another thing you need to be aware of, what if you try to enter a VLAN that is not yet created? It will be automatically created for you. Let me show you that. We don't have VLAN 100 now. Let's say I made mistake and just enter this switch and say switch port. Let's enter the port here. Let's check the port that we have not used. Show. Okay. G0/2 is free. There's a switch port access VLAN 100. You remember we've not created any VLAN 100. What's going to happen? The switch will create the VLAN for us. Look at what it's saying. Access VLAN does not exist. This VLAN I'm trying to access does not exist, but I'm going to create this VLAN for you. And if you go and find out, show VLAN brief. You see that VLAN 100 has been created for us. Look at the name he gave it. VLAN 100/0100. So anytime you try to assign a port to a VLAN that does not exist, the switch will automatically create the VLAN for you. So we need to also be aware of this command, show VLAN summary and show interface VLAN command. So why do we need to issue that command? Let's go to our switch. Show interface VLAN 2. I think it's summary. Okay, packet teaser doesn't support that. Let me just say show interface VLAN 2. So what do I want to find here? You must always say this. I talked about that for physical interface. VLAN 2 is hop, LAN protocol is hop. What is this VLAN 2 used for? For us, we're using it as management VLAN. If LAN protocol is down, this VLAN is not operational. If the interface is down, the VLAN is not operational. So the interface must be operational. These two must be up. So take note of that command. So there are other commands. Then what if you want to remove a port from a particular VLAN? If you switch into a VLAN, you want to remove the port. You go into that port and say no switch port access VLAN. No switch port access VLAN. So if you have put it in a VLAN before, you can get rid of that particular port from that particular VLAN. What if you want to delete a VLAN completely on the switch? You don't want to do VLAN again. You get rid of all your VLAN one after the other, no VLAN, the number, no VLAN 10, no VLAN 20, no VLAN 2, no VLAN 3. And now when you are done with that, you issue this command, delete flash, VLAN.dat, or delete VLAN.dat. Why are we doing that? Because there is a database created for us when we create VLAN, and that database is stored in VLAN.dat. So we need to get rid of that database. We need to clear it up before we reload the switch. So don't forget that. You remove the VLAN, delete VLAN.dat, and then you can restart your switch. Then all the VLANs will be gone. But to restore to factory default, unplug all data cable, erase the startup config. That means you should erase your NVRAM and delete VLAN.dat, then reload the switch. This is even the best way to do it. You erase the startup config, delete VLAN.dat, and then reload the device. All your VLANs will be gone. And then we'll talk about trunking, and then these are the commands on trunking. And one more thing here, you see, we can even decide on the trunks to be allowed on the trunk link. Remember we said our trunk link will carry all VLAN information. What if we want to say, guy, we only have VLAN 2, VLAN 3, VLAN 10 and 20. These are the only people that should be allowed to pass through this link. We know you can carry message for all the truncate, all the VLANs, but now we are telling you only allow this guy to pass. It's another form of security. So you can do that if you want. We can see a good example here. VLAN trunk allow VLAN 10, 20, 30, 99. Only this VLAN will be allowed to pass through that link. Any other VLAN information coming will not be allowed to go through that link. That's a, what do you call it? A security feature. Okay. So you can always remove change native VLAN. And most of the time when you want to remove something, it's the way you put it. Just go and put no. Go and negate it. When you say no, it's negate it completely. And you need to be aware of this port. I mean, this command. Show interface, then the number of the port or the name of the port, switch port. That will give you a lot of details, but I think I will go through more of that in my next class. I am feeling like I'm overloading you guys now. Let me see what is left here. Yeah, we're almost done. Should we just complete this? I need inputs. Give me like 10-20 minutes, I will be done. Ali and everybody, show it. 777, thumbs up. Shut down. 888. I need your. Okay, at least we should continue. Do you people agree with Ali? Yeah, okay. We'll soon be done, guys. Good. So I want to show you the output of this command because there are some things that are key there. This is a cool command. Somebody says 778. You've mixed up my code. Oh, I don't know what you want me to do with that. Okay. So I want to show you guys this command. Let me show you something on this command. And I want to issue it on different ports. We have show interface fast Ethernet. Let's say 0/1 switch port. Don't forget the computer is plugged to that port here. So now this command is good, very good. What is telling us? This is the name of the port. Switch port is enabled. When they say switch port is enabled, it simply means it's a layer 2 port. It's not a layer 3 port. Watch this, please. Administrative mode for this port is dynamic auto. What is dynamic auto? We're coming there now. Operational mode is static access. It's working as an access port now. Administrative trunking encapsulation. The trunking encapsulation, what is the frame tagging we're using now, is .1Q. Operational trunking encapsulation is using native. That is for this interface. Negotiation of trunking is on. What is the meaning of all of this? We are coming there now. I'm going somewhere. Let's check the port G0/1 and see. Zero interface. Oh, switch ports. What's this one? Watch out for this one. This is the name of this port. It is a layer 2 port. Administrative mode for this guy is trunk. Why is it trunk? Because we said switch port mode trunk. Operational mode is trunk. Administrative trunking encapsulation is .1Q. So the information we are getting on this interface is different. Some of them are different from what we are getting on the other side. And why are they like that? Let me show you. So this is what they are trying to explain in this place now. When you say switch port mode trunk on an interface, what happens? you're going to see is going to tell you that the administrative mode of that interface is set to trunk manually. And your operational mode will automatically move to trunk. Your encapsulation is .1Q. We've talked about the .1Q tagging. But I'm going somewhere now. Of course, they said their own native VLAN to 99. That's what you are seeing in this place. Native VLAN is 99 here. So all VLANs created on this switch will pass traffic on this trunk. I'm going somewhere. What if you want to reset the trunk to the default state? You don't want it to be a trunk again. You can enter the interface and say no switch port trunk allow VLAN, no switch port trunk native VLAN. These two commands will reset the trunk to the default state. They will no longer be trunking. I'm still going somewhere. When you say switch port mode access, I talked about this earlier. What are you going to see from the output of show interface faster than a switch port? It's going to show you that the administrative mode is static access and the operational mode is static access. The one I showed you earlier, the operational mode is not static access. The essence of this command is to force the interface not to ever trunk with any other thing, only to connect to computers. So this is where I'm going. There is a protocol called dynamic trunking protocol. And Cisco will tell you don't use it. Disable it. It's not best practice. So why do we need to have it? Why is this still functioning on the devices? Why can't they just get rid of these things on the devices? Let me show you. So what is a dynamic trunking protocol? Dynamic trunking protocol is a proprietary Cisco, it's a Cisco proprietary protocol. What does it do? If I have a switch here and I have another switch here, let's say the switches are 2960 and 2950. Do you know what's going to happen? These links here, they can form trunk by themselves if that protocol is working without my consent. We created trunk by default. We did that. But some switches, when they are connected together, if the protocol is on them, they can automatically form trunking. So the protocol is on 2960 and 2950. And the default configuration on the switches are dynamic auto. What is the meaning of that? We're coming there. But we can turn off that protocol with non-negotiate command. You can see on this switch now, they say switch port mode trunk. Then they now say switch port non-negotiate. When you say switch port non-negotiate, what we are simply saying is we don't want dynamic trunking protocol. We are turning it off because it's a security risk. But what if you want to turn it on again? You can go back and say switch port mode dynamic auto, because that is the default state on those switches, 2960 and 2950. That's the default state. But there is a challenge here. These are different types of the interfaces we can have. We can have our port to be access ports. We can have our port to be trunk port. We've done those ones. But as long as dynamic trunking protocol is up and running on some of these switches, some of them are on dynamic auto by default. Some of them are on dynamic desirable. What is the difference between the two? Dynamic auto is waiting for somebody to say, let us form trunk. So if one side is on auto and the other side is also on auto, they will never form trunk because I'm waiting for you to talk and you're also waiting for me to talk. That's why you need this table. Look at my table here. That's where we're going to end the class. If DTP is on my switches, let's say we have two switches here now, and dynamic trunking protocol is on, even though you are told to disable it. If one end of my port is dynamic auto, and the other end of my port also is dynamic auto, this is what the kind of link they will form. They will form access port. But if one side is dynamic auto and the other side is dynamic desirable, they will form trunk. If one side is dynamic auto and one side is trunk, they will form trunk. You can see that when I turn one side to a trunk the other time, the other one, the link automatically became trunky. Why? Because one side was on auto automatically. Let's go back to that switch. I have removed that command. I've put my switch port mode access there. It won't show me what I wanted to show you guys. So I saw that when I put the command switch port mode trunk on one side, before I went to the other side to put it, the trunking just formed. It's because the DTP is active on this switch by default. By default, this is dynamic auto. I am using 2960 series. The moment I turn one side to trunk, the other one just formed trunk with me. They negotiated. If one side is on auto and the other side is on access, they will never form trunk. If one side is dynamic desirable, the other one is dynamic auto, they will form trunk. One side is dynamic desirable, the other side is dynamic desirable, they will form trunk. If one side is dynamic desirable, the other side is strong, they will form trunk. If this side is dynamic desirable and this one is access, they will never form trunk. If one side is strong, that is manual now, and the other side is dynamic auto, they will form trunk. If one side is strong, the other side is dynamic desirable, they will form trunk. If one side is strong, the other one is strong, manual, they will form trunk. But if one side is strong, the other side is asset, they will never form trunking. And it doesn't matter once one side is access, there's nothing that will happen. Trunking will never happen on the other side. Look at what will happen here. Access dynamic auto will give you access. Access dynamic desirable will give you access. Access to trunk will give you limited connectivity. Access to access will give you access. So we don't want this. So you are told to disable this protocol. How do you disable it? Just say non-negotiate. Let me go back to that switch. Okay, I think that's all. Yeah. Let me go back to that switch and show you something there. Show, okay, still same command. Let me show you something. Look at this thing here. Negotiation of trunking is on. I don't want it. I can disable it. Always disable it. Switch port, non-negotiate. And if it's on access port, like the first one I issued, switch ports, what's that command? Look at negotiation of trunking on. So if somebody should come and try to plug to this port right now and try to form trunking with this port, it will form trunk. So Akka can do something about this. So on that port, what can I do? I can go to that port 0/1 and say switch port mode access. Then this should disable it. Let's check it. Did you see that? Negotiation of trunking is off. So don't ever give the hacker, the threat actors, access to the port on your switch that is not that has DTP enabled. You must always off the DTP. That is the essence of that switch port mode access. But when you're on a trunk link, the moment you say switch port mode trunk, then say switch port non-negotiate, disable it. So I said this doesn't make sense to me. If you people know that it is dangerous for me, why don't you just switch it off by default on the device before you even sell the device to me? And that is where I land this plane. Any question? So we didn't go to inter-VLAN routing. That we're going to do in next class.